Hello, Integrated Math 1. Welcome back to boot camp. Today we are solving equations. Again, you've done this before. There's nothing here that's surprising, shocking. Oh my gosh, how did that happen? No. You've done this before, but it's been a while, so we want to make sure that we jog that memory, that we got you guys ready to go. So don't forget, today we're solving equations, and don't forget, when you solve equation, the goal is to isolate your variable, whether it's an X or a Y or a K or a Z, I don't really care. The goal is to isolate the variable on one side of the equation, on one side of the equal sign. So you have a tool, you have a bunch of tools to help you do this. You know that you undo operations with inverse operations, right? That you undo addition with subtraction, you undo division with multiplication. You know how this works. And you also know that what you do to one side of the equal sign, you must do to the other. That equal sign is a big balance, right? If something happens on one side, it's got to happen on the other side too. So just a quick reminder, if I have a lovely equation like this one, 2x plus 5 equals 17, of course, we want to solve for x. We want to solve the equation. So I need to get x alone. That 2 is really stuck to the x, so I'm going to go for that plus 5 first. I undo addition with subtraction. So I undo a plus 5 by subtracting 5. But if I do it to one side of my equal sign, I have to do it to the other. Some students like to put a big line down they do what they call the box method, where they put a big line through the equal sign. That's fine too. If that works for you, that's what you do. So we're going to subtract 5 from both sides. And of course, the whole reason why we're doing it is because that will cancel these guys out, right? The plus 5 and the minus 5 cancel out. So I now have 2x equals 12 because 17 minus 5 is 12. We have to do it to both sides. I need to get the 2 alone, I need to get the x alone. So I need to get rid of the 2. Remember that when they're next to each other, that means multiplication. We undo multiplication with division. So since I have 2 times x, I'm going to divide by 2 to make it go away. And what you do to one side, you must do to the other. So my 2's cancel out. And now I have 12 divided by 2. So x equals 6. And there you go. So you know this. You've done this before. It's not new, but it's a good reminder. So let's go ahead and jump in then. I've got a couple equations for you guys. Go ahead and jump in and work these out. Do what you can. Don't panic if you get stuck. Try it out. You might be surprised, but of course there are a few tricks along the way, so watch out for that. Go ahead and hit pause to work these out, and then hit play when you're ready to check your work. Now, this first one, you're probably fine. 3x minus 7 equals 26. Great. I will add 7 to both sides to cancel that out. And I get 3x equals 33. Need to get rid of that 3 that's being multiplied by the x. So we'll divide both sides by 3 to make those guys cancel out. And I now have x equals 11. Hooray. The other one might have messed with you a little bit. I'm going to warn you. Please watch out. That minus sign goes with that 4. That's a minus 4x. So that's actually a positive 6. That's a positive 6. So if you want to get rid of a positive 6, you need to subtract 6. I warned you there are some tricks here. So because that's a positive 6, I need to think of it as a plus 6. So I'm going to subtract 6 from both sides. When I do that, these guys cancel out. 38 minus 6 is 32, but I still have a negative 4x here. No big deal. This is a negative 4 that's being multiplied by x. Oh, I hope you caught that as well. So we need to divide both sides by a negative 4 because that's negative 4 times x. So we'll divide both sides by a negative 4. Positive 32 divided by a negative 4 is a negative 8. So we get x equals negative 8 or negative 8 equals x. Either way of writing it is fine. So that one had a few tricks. Oh, sorry. I had to see what you could do. Come on now. I had to see what you could do. Hopefully you managed it all right. And if you didn't, no big deal. Hopefully you figured out what went wrong and you're like, oh, I won't let that get me again. Good. That's how we should be looking at this. I got 2 more problems. They're a little more complicated, but I think you can do it. I think you can do it. Go ahead and hit pause to work these out, and then hit play when you're ready to check your work. You ready? So to take a look at these, how'd you do? Hopefully you remembered an old friend of ours, the distributive property. Did you remember the distributive property? I should point out, this isn't the only way to solve it. This is just what my brain saw. I thought, I'm going to multiply and multiply just to make life a little bit easier. So fine, 3 times 7x is 21x, and 3 times a negative 6 is a negative 8. And now this looks like all of our other problems. I'm going to add 18 to both sides. In fact, it was so easy, I didn't even show all my steps. But I went ahead and added 18 to both sides so that these would cancel out. So I've got 21x equals 63. And then I was like, oh, I'm just going to divide both sides by 21. And that way I got those cancel out and I get x equals 3. So it really wasn't so bad. This one, did you panic over this one a little bit? Did you panic a little bit? I hope you didn't. I hope you remembered that fractions are actually mini division problems. Did you remember that? That this is actually being divided by 4. So if I want to undo dividing by 4, I can just multiply by 4. But of course, if you do it to one side, you have to do it to the other. So we can undo division with multiplication so that those guys will cancel out. And negative 17 times 4 gives us negative 68. And now this is similar to the other problem. Please remember that is a plus 2. That's a minus 5x, but that's a plus 2. So I subtracted 2 on both sides. Did you catch it this time? I hope you caught it this time. Now you knew. Now you knew, right? From last time, now you knew. So I went ahead and subtracted 2 from both sides. A negative 68 and a negative 2, of course, gives me a negative 70. I hope you were careful on that as well. And I still have a negative 5x over here because, of course, these guys, canceled out. That's why we did it. And last but not least, I hope you caught this. This also happened to us last time. That's negative 5 times x. So we'll divide by negative 5 on both sides. And that way that'll cancel out. And a negative 70 divided by a negative 5, well, negative divided by a negative gives us a positive 14. So it turns out that x is 14, or 14 equals x. Either way, I'm thinking about it. Both ways work. So now you know that trick. All right, so now you know those tricks. Good, good, good. All right, I'm going to mess with you just a little bit more. Can I mess with you just a little bit more? Just a little. One more slide. 2 more problems. What are you going to do about these? Go ahead and hit pause, see what you can do with these, and then hit play when you're ready to check your work. All right, so I was looking at this and I had a mild heart attack. I was like, oh, there's 2 x's. There are 2 x's. But notice how my equal sign is over here. My x's are on the same side of the equal sign. That means that I can combine them. Combining like terms, they're like terms. I can combine my like terms. So fine, the first thing I did was combine my like terms. I said, all right, 7x minus 4x, and that's 3x. Great. Still have all the other stuff. I still have that plus 5, still have the equal sign, still 23. And now this is easy. It's just like our other problems, right? Subtract 5 from both sides. So I get 3x equals 18. Divide by 3 on both sides. I get x equals 6. No problem. So since they were on the same side of the equal sign, I was allowed to combine them. This other problem, though, you looked at and you were like, there's 2 x's. There's 2 x's. There are 2 x's. But they're now on different sides of the equal sign. So we're going to get rid of one of them. I don't care which one you get rid of. It's up to you, the order you did it. I decided to get rid of the 2x because he was smaller. And I thought, well, that's a positive 2x, right? That's a plus 2x. Just like that's a minus 13, that's a plus 2x. So I thought, well, I'd better subtract 2x then on both sides in order to get that to cancel out and go away. So I now have negative 13. 6x minus 2x is 4x. And I still have that plus 3. And now it's no problem, right? We'll subtract 3 from both sides. So we get negative 16 equals 4x. And we'll divide both sides by 4 to get the x all alone on his own. And negative 16 divided by 4 is a negative 4. So x equals negative 4. Or I wrote it as negative 4 equals x. Both ways are correct. Both ways are saying x is a negative 4. Whew, so we had a few tricks along the way. Again, nothing new, just jogging our memory and getting things going there. I hope this was helpful. As always, if you got questions or concerns, please let me know. Email me, come see me during office hours, come talk to me. I'll help you get sorted out. And I'll see you guys soon. Bye.